The church was built about 150 years ago. And when I say the church, it was a square box up to about where I'm standing. And then 10 years after that, they built the front end of it, what they call the transept, where it intersects with the larger building. And when they did that, they added the Gothic plaster ceiling below the ceiling that existed in the original construction. So when they built the new addition, the posts that we were talking about not only held up the roof, but they held up the new ceiling. We came in one day and half of one of the capitals at the top of the pillar, the plaster capital, was on the ground. It had cracked and fallen, and we were looking into having it repaired. In the process of doing that, we noticed that the post that was underneath, which is about 140 years old, had a crack in it. So we had an engineer come and look to see if there was an issue with the post and why the capital fell.
They had some roof damage that caused a lot of water leakage. That water leakage came down and got inside of the column capitals, rotted out the plaster capitals, and then also the columns themselves.
The crack pretty much went from the ceiling that you see to the floor, but it didn't go above the ceiling and it did not go below the floor. They did not feel that it was structural, but they also noticed that the decorative wooden outside held up the capital, and the capital held up what in essence is the ceiling above it. There was mostly plaster with just some wood inside of it. There really was no continuity between the wooden ribs that hold up the plaster ceiling and the wooden casing on the outside of the post. It was just the plaster capital. The capital was not enough to hold up the ceiling, even though it's been doing it for about 140 years.
Those columns needed to be beefed up, made structurally sound, and then the column capitals had to be replaced. Unfortunately, they're made out of plaster, and there's really nobody that makes those anymore that we knew of.
We ended up adding about 7 inches on each side of the post to create enough structure to hold up the ceiling. So then the decorative outside of that post had to get larger. And then recreating the capital became a question whether that was necessary to do it in plaster or some other medium.
It just kind of came to us as we were talking that we had seen some recent articles about some neat things that have been going on with 3D printing. What if we 3D printed this? Hey, maybe this is a possibility. Maybe this is something that could help us out in this situation.
We've never 3D printed anything of that scale before. Mostly it's been smaller parts and pieces. But the technology, it works. It's faster, it's cheaper, and the lead time is much shorter.
It became clear very early on that, yeah, this was something that could very much be a viable solution for us.
We brought in a 3D laser scanner. We took that scanner and scanned basically the whole inside of the church. The 3D laser scanner, it's a machine that sits on top of a tripod, and it spins around and shoots millions of points out per second, and it takes note of how far away each point was from the tripod and what color that point was. So what we end up with is a 3D picture of what the inside of a facility looks like. We can take that picture and then trace over the top of it. That gives us the shape of the column trim. It gives us a real good picture of what that column capital looks like. So then we can take that and kind of convert it from point cloud to a model object that can be printed.
We're talking just a massive print that was spread between 2 printers. We're over 50 kilograms worth of material.
I think one of the things that we're learning throughout this workflow or this process is that there's a lot of different aspects to how these parts come to fruition.
This took a lot of hands. Took a lot of people to touch this project to get it from start to finish. First off, we got the part to begin with, and it was a huge column, and we had to even wrap our minds around how do we even begin the process of printing this gigantic structure. So the things we had to consider there is, for one, what is printable, what has support overhangs, what's going to be the easiest to clean up. How are we going to put this together? We had the size capacity to do the part in one shot, but that's 15 days on the printer without stopping, and that's terrifying. And that's just for one. So if anything, you have a power blip, something weird happens, someone pushes a button, in 15 days, you lose the entire build and you have to start over. We ended up printing this in each section in 12 different pieces. So we quartered it and then cut it in thirds based on how it was going to need support was going to be needed. And then I had to figure out how they would fit on the bed, what material to use, what supports that need to be put in place for overhangs. As you can see on the part, we have a lot of overhangs here. And so we had to come up with a way to print from here to hold this overhang up, so because you can't print over open air. So figuring out how to put supports into here, where to put them, how to put them, was a very time-consuming process. A lot of considerations from start to finish on this project. The last step was to figuring out how to ship these massive structures. We combined 6 of the pieces out of each build, so we were shipped in halves, so 4 halves, and we had it in a 2-story box that had to be built. So just from the start to finish, there's very hands-on, a lot of little components that you don't necessarily think about on the front end.
We're talking about something, an object that normally, if it was carved out of wood or made out of plaster, could weigh upwards of a couple hundred pounds, and now we're going to have an object that might weigh 10 pounds being 3D printed out of plastic. So just the potential that has inherently in it for our construction workflows moving forward. There's some really exciting things that could be coming down the road if this works out the way we think it's going to.
It was a ton of fun. I had a blast on this project. It was a tough project and a long project, but very rewarding at the end, getting to hear the feedback of how much they enjoy it and how much they like it.
So once the capitals were installed, then we could put on the finishing touches. They were primed and painted, and then a gold leaf was applied to part of them to match the existing capitals. Gold leaf is 3.75 carats, and we had the option of using fake gold leaf, and we chose the real one because it looked more like the existing capitals. The final results are actually spectacular. It was a long time in coming. It was a lot of pre-planning, finding the right people to do the job, finding the right millwork, getting the engineering all done. But in the end, I think the best compliment I could give to the people who put them together is that they don't look like they've been replaced. They match exactly with the decor of the church, and they fit in with all of the other capitals, columns, and millwork in the church. Again, the final product is beautiful.